Greetings everyone. So in this video we're going to cover the basics of trigonometric functions. But before we do the more practical stuff, we can first think about the terminology we might find in our trigonometry lesson series. So we really need to familiarize ourselves with this terminology. Firstly, you have to know what is a range. So as I've said, a range refer to y values a function can have. So it's all about what are the possible y values for that specific function. It's kind of self-explanatory. For the domain, it's almost the same thing, but the difference is that the domain is concerned with x. So for the domain, we refer to the x values a function can have. That means what are the x values possible for this specific function? That's what we basically mean. Then for the period, we refer to the number of degrees a graph takes to complete one cycle. That means how many degrees does this function take to complete a full cycle. When I talk about a cycle, maybe something like this, or yeah, if it's sine, if it's cos, maybe something like this. So how long does it take cos to fully look like this? That's what we term as a period. After how many degrees does sine assume this position? That means starting and ending in a similar way. I'm trying to say that. Then that's what we term as a period. My drawings might not be as accurate, but this will make more sense as we do the examples in the next few minutes. So with the amplitude, amplitude is just the half of the difference between the maximum and the minimum value. So halfway between the maximum and the minimum value, it's what we term as an amplitude. So how do we get the amplitude? It's maximum value minus the minimum value divided by 2, because we say it's the difference, so that's why we're using the minus sign. So I guess this was clear. So in the next slide we'll have I think 2 functions. Then we will try to find the range, domain, period, and the amplitude in those 2 functions. I just decided to use just a single graph because I was struggling to draw them in one plane. Not really because I can't, but I struggle to draw. So I'll try to focus on the sine graph first, then I'll move on to the cos graph. So this is a function for y is equal to sine x. That means it's the parent function for sine. So this is y is equal to sine of x. It's going to be beneficial for you to know this function, because when the shifting and everything occurs, at least you will have an understanding of the parent graph. So let's first think about the domain. As we need to remember that the domain is concerned with x. So the domain for this function, or firstly, what is the domain? So the domain, but I mean by the domain we mean the x values a function can have. So how many x values, like when you think about x values, you think about the axis. So if you check here, you might say x is, or this graph can have the x values from 0 to 360, but that's not true. If I can extend it, let me show you. Maybe if I can try to extend it, that means I can still find other x values as I move to my right, which shows that the domain here, we can't really have actual numbers for the domain, but we can say x is an element of real numbers, meaning any real number is possible in this function. Like any real number for x is possible because it ends at 360, yes, but it can go to 500, it can go to 1000. It's still possible for us to get an answer when we plug in a value of 1000 for x in the equation y is equal to sine x. So as long as we can get an answer when we say y is equal to sine, then we put any value of x, but still we get an answer in our calculator. That means our function is still defined within that domain or within that series of x values. Then the range is concerned with y, the y values. So if we think about the range, I forgot to put 1 here, and here it's -1. It's -1. So if you think about this, 1 is the maximum value and -1 is the minimum value for this function. This graph cannot go here. This graph is undefined here because its turning point is right here. So we can't have any number below -1, and we can't have any number above 1, and this is the y-axis. This is the y-axis. So the domain is concerned about the y values possible for a specific function. So you see now there is no number possible for y in this function if y is less than -1. That means the smallest number possible in this function is -1, and the biggest number we can have is 1 because we don't have a function here. The graph turns at 1. 1 is the turning point, is the y turning point actually. So we can't have any number bigger than 1. That means 1 is our maximum. So the range, meaning our graph ranges for y, it ranges from -1 to 1. You can't have any number outside this range, because if you can plug in for y, you put any number and you try to solve for x, it will say undefined if that number is greater than 1 or it is less than -1. That means our graph is only defined at a space between 1 and -1. As you can see that it's from 0, then at 1 it turns 0, -1, at -1 it turns and it goes up, and at 1 it will turn again and go down, and at -1 it will go up to a certain x value we don't know, but within the y values it can't exceed 1 and it can't be below -1. Hence we say the range is from -1 to 1. I think I over explained this. Then the amplitude, we can think now about the amplitude. So as we said, the amplitude is half the difference between the maximum and the minimum value. Amplitude is half the difference between the maximum and minimum value. Like maximum and minimum value, those are self-explanatory terms. So when you're looking for the amplitude for the function y is equal to sine x, you can calculate the amplitude. Amplitude is equal to maximum value minus minimum value, all divided by 2. Then we can say, what's the maximum value? Maximum value is 1 minus this minus the minimum value. The minimum value is -1. So you can say minus, open brackets, -1, all divided by 2. So 1 minus -1 divided by 2, that is 1. So our amplitude is 1. And if you check here, really the amplitude is 1 because it's from 0 to 1. That is where we get our maximum. And it will, and here, even though it's on the negative y-axis, but if you check from 0 for y to -1, you move 1 unit or you move 1 step. So it still shows you that your amplitude is 1. I think I need to stop here because I've exceeded my 8 minutes maximum to 11 minutes. Then we're going to continue to more deep or to more complex problems in these lessons for trigonometric functions. But I guess I need to stop right here and we will continue in the next video.